Let's look at the last problem in homework 6, relating activation energy to a reaction rate. This one looks really tricky. It's giving us two different reactions, and the two reactions have the exact same reactants, A and B, but one reaction gives us product C and one reaction gives us product D, and then it's going to give us some information about the two reactions, and we have to sketch an energy diagram. So given the information, we know that both of the reactions are endothermic, which means that they're going to be going uphill in energy, but the heat of the reaction of reaction 1 is larger. So, and also it tells us D is produced faster than C. So this is going to be tricky. So the first thing that we need to do is start our reactions off. And because both of reactions are starting with A and B, their position on the two diagrams has to be the same, the way I've drawn here. Like you can't go like this. You can't have A and B being higher in energy in one reaction than in the other. They both have to be the same. And activation energy, which is going to be this middle dot here, is always higher than your initial reactant. So it's going to be somewhere up here. We might have to, we're going to have to move it around. And because we know that this is an exothermic reaction, I'm actually going to move my A and B down a little bit. And I need C and D to be higher in energy than my reactants. But I don't want C and D to be equal in energy to each other because they're two different molecules. So I don't want them to be exactly the same. So I'm starting here. Now I'm going to go back and read some more about my facts about the reaction. Both of them are endothermic. We've got that covered. But the heat of reaction 1 is larger. So that means the difference between the products and the reactants needs to be bigger for reaction 1 than for reaction 2. Like I've done that. The difference between C and A and B is greater than the difference between D and A and B. And then what else does it say? If a reaction vessel is filled with A and B, then at first D is produced faster than C. Ooh, that's tricky. So what that means, if D is produced faster, that means it has a smaller activation energy, which means we need to move this down. The rate of the reaction depends on how hard is it, how much energy does it take to go from A and B up to that high point on the curve. So let's move, we're gonna move the activation energy down for reaction number 2. That way it'll go faster. And let's double check that I haven't messed anything up. My A and B are still in the same spot. The reaction is still exothermic. The difference between reactants and products is still greater for reaction 1. So this looks good. We'll see if ALEKS likes it. Yes, it did. Let's look at another one like this. So same thing again, we're starting with A and B. Let's just kind of put them, and they got to be at the same spot initially, so let's put them there. And our activation energy has to be higher. So we'll just give ourselves a positive activation energy. Now let's look at the information. Following facts are known. Both reactions are exothermic, so that means we have to go downhill. A and B have to be higher in energy than either one of our products. And I've got that covered. So my products are lower in energy, but they can't be the same. C and D have to be different. So we'll make them different. And what else do we have in our facts? Both of them are exothermic, but the heat of reaction number 1 is larger. So that means that the difference between reactants and products needs to be bigger for reaction 1. And I've already got that. C versus A and B. Oh, that's not what I wanted. So I've got a bigger gap between C and the starting point. D versus its starting point, that's a smaller gap, so I'm good. Next fact, if a reaction vessel is filled with A and B, then at first D is produced faster. So that means that I want my activation energy, looking at the two activation energies, I want my activation energy for reaction 1 to be higher. I don't think I can get it any higher. So reaction 2, I need to make it lower. Move it down, ALEKS. I need to have a lower activation energy for reaction 2 so that reaction can go fast.